Hey everyone, I'm here to talk about Chapter 5. This is lesson number 6, and we're going to talk about the increment and decrement operators. We're going to talk about while loops, do while loops, and for loops, and we're going to see how we can use it to solve some common programming problems. Alright, to start things off, let's talk about the increment and decrement operators. So this is a little plus plus or minus minus that we can put, and I'm going to skip over this for a second, that we can put next to a variable name. So if num is an integer, it's going to increase the value of num by 1. If we use minus minus, it's going to decrease it by 1. Now you'll notice that you can put the increment or the decrement operators either in front or behind a variable name. And that doesn't really have a big difference if it's not being used with anything else. So let's jump over to our compiler here. Oops, don't look at that. So let's go ahead and print out the value of this num variable. Okay, and we'll just go ahead and use the increment operator here to change the value. So this should print out the number 1. Let's go ahead and run it and see what happens. So let's see, we get 1. So it was 0, we incremented it by 1, and then it printed out that value. Alright, I'll spare you from having to see the decrement operator. I'm sure that you can guess that that would then instead print out -1. But let's go ahead and use it as a post-increment, I'm sorry, a pre-increment instead of a post-increment. And run it again, and we'll see that it is going to print out the number 1 again. So it didn't have any effect whether we put it on the right or the left hand side. In other words, it didn't make a difference if it was a pre or a post increment operation. Now the place where it will make a difference is if you combine a pre or post increment along with another operator like the stream insertion operator or an arithmetic operator or a relational operator. Then you do have to think a little bit about what you want to do. So let's go ahead and just take this out and then come back to here and make this a post-increment operator. Now the way this works is if it's a post-increment operator, it's going to use the value of this first for this operation, and then after it's done, it will then perform the increment. So what should happen here is it should print out the number 0, and then if we did another cout down here, is the first time that we do a cout, it will print out the number 0. It will then increase it to 1, and down here what we should get when it prints out is the number 1. Let's see if that happens. So we get 0, and the value after cout is now 1, because we did a post increment. Alright, now let's go ahead and flip it around and put it on the other side and make it a pre-increment. So now what should happen is it should increase the value of the variable before it does the operator. So this time it should print out the number 1, and then down here it will still be 1. So there we go, 1, 1. Alright, and that's pretty much everything we need to know about the increment and decrement pre-post. There's also, I skipped over this shorthand here for this type of operation. It's very common to increase or decrease a variable by not necessarily 1, but by some fixed amount. So if we wanted to do something other than increase it by a value of 1, which is what this does, we wanted to increase it, say, by like 10 or 100 or 5, or increase it by multiplying it by 2 every time. We can use as a shorthand this operator right here to increment or decrement by a non-1 value. Alright. Moving along. They say that people stop watching after 5 minutes, so I'm going to try to be very brief in these videos. Let's see, what do we got to next? So then down here they're just going to show you some examples of the pre or post increment using other operators like multiplication. So down here, same thing, because it's a post increment, it's going to apply the value to the multiplication first, and then when it's done, increase it. So down here, We got b is equal to 5 and a is equal to 2, so 5 times 2 is going to make c equal to 10. And then it will increase b from 5 to 6, which is, I believe, basically everything that they just did down here. So you can see that it would print out a, b, c, which would be 2, 6, 10, because again, 5 times 2 is 10, and then it increases the value by 1, thus it goes up to 6 when it prints out b. Alright. Down here, we're going to do a pre-increment, so it's going to take b, it's going to multiply it, or I'm sorry, it's going to increase it by 1. So 6 times 2 is 12, and then it increases the value, or it already increased the value, so we get 2, 6, and 12. Alright, yeah, don't do this, that's bad. Okay, moving along, let's see. They just give you more examples here of how it changes using relational operators, but it's just the same idea. So down here, it's going to decrease it after it checks the value. So it looks at x first, and x is 10, which is not greater than 10, so it would never print out this line down here. And then x would get increased to 11 after this is done. Okay, moving along, loops. Alright, so I said that there are 3 different types of structures in any program, no matter how complex they are. There's sequential control structures, there's branching control structures, and there are looping control structures. The way a looping control structure works is just like in this little diagram here. You are going to evaluate some type of expression, which is usually in the form of something that will evaluate to true or false. If it's true, you execute any statements that are associated with that loop, and then you come back to check if the expression has changed. When it becomes false, you stop. Now, the main thing I want you guys to notice about this version of a loop is that there's the possibility that you come in, you test, and the condition is false, and you never actually execute any of the statements. And the book kind of delays this, but this is what is called in the business as a pre-test loop. So you should know that for a quiz and exam, that in a pre-test loop, there's the possibility that none of the instructions or statements inside the body of a loop will ever execute. So what does a while loop look like? It looks like this. We have the keyword while. In parentheses, we put our expression, and then we have any statements. Just like with an if control structure, if we have more than one statement, we enclose those in a block using curly braces, just like you see here. Alright, let's look at a simple example of a while loop. So here we have a variable called number that we're initializing to 0. We check to see if 0 is less than 5, that's true, so we print out hello, and then this is a very important step. We increase the value of number before we come back up here and check it again. So this time the value of number is 1, 1 is less than 5, so it prints out hello. So essentially we get a program that prints out the word hello 5 times. Now, why is this important? This is important, and again, the book kind of jumps around a little bit, so I'll jump down towards talking about it. Is this problem here. If we initialize this to 0, and we check if it's less than 5, it's true. So we print out the word hello, but then we never modify the value of number. So this will print the word hello forever until somebody turns the computer off. It'll stop your code. So that is what is called an infinite loop. It's a loop where the condition will never change and it's always going to be true, so it'll just keep running and running and running, and this is a very common error. Alright, let's see. Alright, so we talked about that. Jumping down to here, this is something I showed you guys with the if statement. It's a common mistake to accidentally include a semicolon right after the condition, and in which case this is an infinite loop, because remember, it's going to treat this as a null command. So it's like if I put that semicolon right down here, it would just run forever, because we would have a situation just like this where number never changed. Alright, how am I doing on time? I've already been talking for 9 minutes. Okay, so I'm going to go ahead and move down. So yeah, that's the thing. This is not a syntax error, unfortunately, but it's a logic error. Okay, don't forget the braces. So just like we talked about with an if statement, just because you indent something, that does not mean that the compiler understands that that's supposed to be a block of statements. You have to put curly braces here. So this is yet another example of an infinite loop. It's going to print out hello, but number is never going to change because it's going to just stay looping here on the single command. So again, anytime you have more than one statement, make sure to enclose it in curly braces, like this. Okay, let's see. More stuff that you can do that you shouldn't do. Just like with an if statement, you can put it all in one single line like this. There's nothing, this is not a logic error, this is not a syntax error, this is just hard to read, so you should avoid doing things like this. Alright, moving along. This is an important section because this is something you're going to need to do to solve the lab problem. So this is your reward for sticking in here for 10 minutes with me if you are stuck on what to do for the program assignment or the lab assignment. So this is going to do input validation. What we're doing here is we're assuming there's some type of menu system. And this would be a very big menu with 100 different choices on it, but we're going to say that we want to force the user to input a number between 1 and 100. So we grab that number from the user, and then we check using a range. Now we know when we're checking to see if something is outside of a range, that we are going to use the OR logic operator to do that. If we were checking to see if something is inside a range, we would use the AND operator. So here we are checking, is the number less than 1? That's not a menu choice. Is the number greater than 100? That's not a menu choice. If so, we force the person to continue entering numbers until they enter a valid number. So we say, hey, sorry, you can't do that. Put in another number. Read in a number, and we loop and loop and loop and loop until the number is between 1 and 100. All right, so I'm going to jump over to the lab. All right, and let's take a look at what we need to do for Lesson 6, Project 1. Excuse me. Write a program that prints a menu, and it's going to ask the user for a number between 1 and 3 to do an addition or a subtraction problem. So here's an example of what your program code should look like. So print out some type of greeting, and then please choose from the following. 1 is addition, 2 is a subtraction problem, 3 is to quit. And then here we're saying, enter a choice between 1 and 3. Well, that should look somewhat familiar to you. That's exactly what we're checking on right here. We're checking to see that they provided a number within a range. In this case, not 1 to 100, but did they put a number from 1 to 3? Keep going to the wrong thing. Okay. Once the user makes their choice, then you should randomly generate a number between 0 and 10. So use the formula that I gave you guys in the last lecture that we had face-to-face before the world came to an end. And remember, it's at max number, min number, use rand, and remember you got to seed the rand before you use it. Alright, and then you should tell them if they answered correctly or incorrectly, and then it should just continue on that loop until the person chooses 3 to quit. So let's look down here. Alright, so here's an example of running the program. So first off, note that they can choose a math problem as many times as they want. Okay, so the program should loop forever until they choose 3 to quit. So down here they chose 1, which is addition. So we randomly generated the number 2, randomly generated the number 4, asked them for their answer, and they wrote 2. And then in this case, the program should respond that that is incorrect, and the correct answer, 4 plus 2, is 6. So this is an example run where the person chose an option correctly from the menu, but they entered the incorrect choice. Okay, down here, they're going to, again, select an addition problem. Randomly generate 8, randomly generate 2. So ask them for the answer, they wrote 10. So maybe I should have changed this to say your answer instead of just answer. So they're going to put 10, and then you're going to tell them they're correct. Down here, we're going to just give an example of them choosing invalid menu item choices. So down here, they asked for a number, they chose 7, invalid selection, they do a wrong number again, until they finally put 2, which is a valid selection, which is a subtraction problem. And then here we get tricky and we ask them to give an answer that's going to have a negative value. So 7 minus 10 is negative 3, and we say that's correct. And then finally, down here, they choose to quit, and we tell them thank you for using the Math Tutor program. So we got 2 loops going on. We got one loop that is constantly printing out this menu of choices, and a second loop that is inside of that is validating their choice. So I gave you some skeleton code down here to work with. So obviously we need to use the srand function to make it so the numbers are truly random, display the welcome message, print the menu at least once. Now I'm going to go ahead and jump back to the book, because to do this we're going to use a different kind of loop called a do while loop. Now I don't really need to get into the book to explain this. Like, we can just look at the code here to see what's happening. So in a do while loop, notice that unlike a regular while loop, you're guaranteed that the loop is going to execute at least one time because we don't check on the condition until we've executed all the statements inside of the block first. So we know that we're always going to need to print the menu once. So we're going to go ahead and do that once, and then the person is potentially just going to quit, right? That they look and they're not feeling the vibes to do some math problems, so they just hit 3, and then you just say, hey, okay, thanks for using the program, and then you quit. So that's what we're checking down here with the variable called choice, where as long as the person put either 1, 2, or 3, put either 1 or 2 to do either a math problem, an addition problem, or a subtraction problem, then we are going to stay inside this loop. But as soon as they put 3, we're going to stop looping. Now you may say, do we need to do some kind of error checking here? Well, we don't, because we're going to check for it here. So after printing the menu, we're going to validate the input by looking at the number to make sure that it is a number between 1 and 3. So we're guaranteed once we get past this point in our program that the user has provided either the numbers 1, 2, and or 3 to choose their math problem. If they choose, and then here, once we know that they gave us a valid choice, we're going to use a simple if else statement, because choice 1 is going to be for an addition problem, choice 2 is going to be for a subtraction problem, and choice 3 is to quit. All right, we don't need to use the else here as a default because we've already done our validation here where we got the range. Okay, so going back to here, what do I keep doing that? Here. This chunk of code right here is what you're going to stick into your program right here. Validate the input. It's going to be that while loop where you're using an OR logical operator to check if it's within the range of 1 to 3. Hopefully that makes sense. Hopefully that helps you out with the solving the lab problem. The rest is fairly straightforward. It's things we've done before. We're going to create 2 random numbers between 0 and 10. You're going to display the problem using those 2 numbers. Check to see if they got it right, and then we're going to use an if statement down here where we say if the person got it right, tell them they got it right, otherwise they got it incorrect, and tell them what the correct answer is. And then you're going to basically copy and paste this code down here for choice number 2, except for you're going to change all the addition into subtraction. Alright, that's it. That's how you guys are going to solve this project. Hopefully that helps you guys out. I guess I could go through a little bit more here in the book. So let's skip past. Okay, so we talked a little bit about the do while loop. So I did mention that the do while loop, the big difference is that it is a post-test loop. So it is going to execute the statements at least one time and then check the expression. So that's one big difference you should know for a quiz and exam between it and a while loop. Here's the other big weird difference. There's a semicolon that goes after the condition. So unlike a while loop or even an if statement where you shouldn't put a semicolon, in a do while loop you do have to put a semicolon at the end of it, otherwise you'll get a compile error. It won't compile. Alright, so make sure you know those 2 differences. Okay, I'm going to go ahead and skip through here really quick because I do briefly want to mention for loops. The for loop. Okay, a for loop. So something you should know about a for loop. A for loop can be rewritten as a while loop. So everything you can do with a while loop, you can do with a for loop. So you may say, well, then why even have a for loop? So for loops are commonly used if you know the number of iterations that the loop is going to perform. Now, in the example of the do while loop and the error checking loop that we just saw, we don't know how many times it's going to be looping because the person could put 5 incorrect choices, 10 incorrect choices, could get it right the first time. We don't know how many times it's going to loop. All right, the same thing is true with the do while loop. We don't know how many times it's going to print that menu out. We don't know how many times the person's going to want to solve a math problem. So with a for loop, usually the idea is that we know ahead of time how many times we're going to loop. Whether we know it as a programmer or we're going to ask for a number from the user and we're going to loop based on that number of times. So that's the idea. So what does it look like? For loop looks like this. We use the keyword for, and then inside of it we have an initializer, a test, and then an update to prevent it from being an infinite loop. So a very common way to write it is something like this. Here we say for count is equal to 0 while count is less than 5, increment count by 1. So this is the same loop that we had at the very beginning of the book where we did a while loop that printed hello 5 times. This for loop does the same thing. Now note over here that we don't have a variable type. So there's an assumption here that this has already been declared. The book just didn't show you that. Now having said that, this is fairly uncommon to do it this way. Usually you declare the variable type right here in the initialization when you use a for loop. So more common is for something like what they mentioned way later on, here, defining the variable in the for loop's initialization expression. So note that here, they're not just saying num is equal to 0, they're saying int num. So they're actually declaring the variable here, and then they're just using that throughout. So we're assuming min number is some constant, max number is some other constant. So while num is less than max number, do the code that's inside here. And don't worry about what this code is actually doing. All right. And I am going to leave the rest to you guys for the reading assignment. Make sure that you follow through here. It talks about just getting a variable from the user to determine how many times you loop. So for example, down here, we're going to get a number called min number, and then we are going to be using that to initialize another variable called num. So the user is going to provide the value. We use that to initialize num, and then that controls how many times the loop cycles. So that's just an example of letting the user decide how many times the for loop goes instead of you as the programmer deciding how many times the for loop goes. All right, and just like other things, you need to use curly braces if you are going to execute a block of statements in your for loop. Alright, I think this is a good place to stop. Hopefully that helps you guys with the lab assignment, and I hope you guys are all staying healthy and safe out there. And I hope to see you guys again soon before the end of the semester.